For most of human history, food has been the silent architect of our world. It is a story that begins not with kings or conquests, but with a single seed planted in fertile soil. 10,000 years ago, in the crescent of land arching across the Middle East, our ancestors made a revolutionary discovery: how to cultivate crops and domesticate animals. This was the dawn of agriculture, the single most significant event in our species' journey. It allowed us to transition from nomadic hunter-gatherers to settled societies, laying the very foundation for civilization as we know it. With a stable food supply, populations flourished. Villages swelled into towns, and towns into the first great cities. Every city, every empire, and every culture grew around the fundamental question of how to feed its people. The granaries of Egypt fueled the pharaoh's monumental ambitions. The vast road networks of Rome were built not just for legions, but to transport grain from distant provinces to the heart of the empire. The quest for food security shaped trade routes, sparked conflicts, and drove innovation, from the first irrigation canals of Mesopotamia to the terraced farms of the Andes. For millennia, our destiny was written in the soil. But in the last century, the scale of that question has transformed beyond anything our ancestors could have imagined. We are living through the most rapid expansion of human population in history. In 1950, there were 2.5 billion people on Earth. Today, there are over 8 billion. And as the world's population races toward a projected 10 billion by the year 2050, that age-old question is changing. It's no longer just about feeding more people, it's about feeding a more prosperous, more urbanized, and more demanding global population. As billions are lifted out of poverty, their diets are changing, shifting towards more resource-intensive foods like meat and dairy. The demand for food is set to increase by more than 50% in the coming decades. The pressure on our global food system is reaching a critical point. For generations, our answer to rising demand was simple: expand. And we cleared forests for farmland, diverted rivers for irrigation, and developed powerful chemical fertilizers and pesticides to boost yields. This industrial model of agriculture fed billions and fueled progress, but we are now confronting the staggering ecological cost of that success. Agriculture is the single largest driver of deforestation and biodiversity loss on the planet. It consumes 70% of the world's fresh water, often depleting ancient aquifers faster than they can be replenished. It is also a major contributor to climate change, responsible for nearly a quarter of all greenhouse gas emissions. The very methods we've used to feed ourselves are now threatening the long-term health of the ecosystems that sustain us. The challenge, therefore, is no longer just how to produce more food, but how to do it sustainably, efficiently, and without destroying the planet that feeds us. We must grow more with less land, less water, less waste, and a dramatically smaller carbon footprint. This monumental challenge is sparking a new revolution in agriculture, one that is unfolding not in the fields alone, but in laboratories, data centers, and vertical farms. This is the story of the agricultural revolution that's happening right now, one powered not by oxen and plows, but by data, drones, and DNA. It's a revolution driven by innovators, scientists, and farmers around the globe who are reimagining how we grow, distribute, and consume food. They are harnessing the power of artificial intelligence to apply water and nutrients with surgical precision. They are using gene editing tools like CRISPR to develop crops that are more nutritious, drought resistant, and less reliant on chemical inputs. They are building farms that reach for the sky, growing fresh produce in the heart of our cities, and even cultivating real meat from animal cells without the animal. This is a story of hope, ingenuity, and the human capacity to solve the greatest challenges of our time. It's a journey to the frontiers of science and technology, where the future of our food is being written today. We will explore the breakthroughs that promise to feed our growing world while healing our planet, ensuring that every person has access to safe, affordable, and nutritious food. This is the future of food, how agricultural innovation is feeding the next billion. It begins with a paradox. We already grow enough food to feed every person on Earth, yet more than 800 million people still go hungry. Meanwhile, agriculture is responsible for about a quarter of global greenhouse gas emissions, consumes 70% of our fresh water, and drives massive deforestation. The problem isn't just production, it's distribution, waste, and inefficiency. To fix this, the next agricultural revolution must be not only about yield, but about intelligence. Across the planet, new technologies are reshaping farming from the soil up. In India and Africa, small farmers are using satellite data and mobile apps to optimize planting times, detect pests, and monitor rainfall. In the Netherlands, vertical farms grow lettuce and tomatoes using 90% less water than traditional agriculture. And in Japan, robots harvest rice and strawberries with surgical precision. These innovations may look futuristic, but they're already transforming the economics of food. One of the most profound breakthroughs is precision agriculture, farming that uses real-time data to make every drop of water and every seed count. Drones equipped with multispectral cameras scan fields for signs of stress invisible to the human eye. Sensors embedded in the soil monitor moisture, nutrients, and temperature. Artificial intelligence then interprets this data, allowing farmers to irrigate and fertilize with surgical accuracy. The result? Higher yields, lower costs, and dramatically reduced environmental impact. But the revolution doesn't stop in the fields, it's happening in the lab. Scientists are now editing the very code of life to make crops that are more resilient to heat, drought, and disease. Using CRISPR gene editing, researchers can enhance photosynthesis, increase protein content, and even reduce the need for pesticides. The goal isn't to repeat the mistakes of the first green revolution, which boosted yields but damaged ecosystems, but to create smarter crops that work in harmony with nature. Another frontier is alternative protein. Our demand for meat is soaring, but livestock farming is one of the biggest contributors to deforestation and methane emissions. Companies around the world are now developing plant-based meats and lab-grown proteins that look, taste, and cook just like the real thing. Singapore became the first country to approve cultivated chicken for commercial sale, marking a turning point in how we think about food itself. In the near future, your burger could be grown in a bioreactor instead of a pasture. While our technological advancements reach for the stars, a quiet but powerful revolution is taking place right under our feet. It's a movement that looks to the past to redefine the future of how we feed ourselves. This is the story of regenerative agriculture. For much of the last century, the dominant model of farming has been an industrial one, a system built on maximizing yield through intensive tilling, monoculture crops, and a heavy reliance on synthetic fertilizers and pesticides. And this approach fed billions, but it came at a cost. Year after year, we treated soil like a sterile medium, a mere anchor for plant roots, rather than the living, breathing ecosystem it truly is. The result has been widespread soil degradation, a loss of vital biodiversity, and the release of immense amounts of carbon from the land into the atmosphere. But what if we could reverse this trend? What if farming could not only stop causing harm but actively start to heal the planet? Regenerative agriculture offers a compelling answer. It's a philosophy of farming that brings ancient wisdom back into the modern age. Instead of fighting nature, regenerative farmers work with it. The core principle is simple yet profound. Give back to the soil more than you take. This means shifting focus from a purely chemical and mechanical approach to a biological one, understanding that the foundation of a healthy farm is healthy soil. And healthy soil is not dirt, it is a complex, thriving metropolis of bacteria, fungi, protozoa, and countless other organisms. This microscopic world forms a symbiotic relationship with plants, a partnership that industrial agriculture has often ignored or destroyed. The practices are guided by nature's own playbook. One of the key tenets is minimizing soil disturbance instead of aggressive plowing, which breaks up the soil's structure and releases carbon. Farmers use no-till or low-till methods, leaving the delicate underground ecosystem intact. Another vital practice is planting cover crops. These are not grown for harvest, but to protect and enrich the soil between cash crop seasons. Their roots hold the soil in place, preventing erosion from wind and water. They also feed the soil's microbial life, and when they decompose, they add precious organic matter back into the earth. Diversity is also crucial. Regenerative farmers move away from monocultures, instead rotating a wide variety of crops and integrating livestock back onto the land. Animals, when managed properly, are not a problem but a solution. Their grazing stimulates plant growth, and their manure provides a natural, potent fertilizer, closing the nutrient loop and restoring the carbon cycle. The benefits of this approach are transformative. Healthy, living soil, rich in organic matter, acts like a giant sponge. It holds water far more effectively than degraded soil, making farms more resilient to both drought and flooding. This increased water retention means less irrigation is needed, conserving a precious resource. It also means less runoff of agricultural chemicals into our rivers and streams. And critically, healthy soil captures and stores enormous amounts of atmospheric carbon. Through photosynthesis, plants draw carbon dioxide out of the air. In a regenerative system, much of that carbon is channeled through the roots and sequestered deep in the soil, where it can remain for centuries. This process turns farmland from a source of emissions into a powerful carbon sink, making farmers frontline heroes in the fight against climate change. This approach is not a distant dream. It's happening now, and it's gaining momentum across the globe. In the American Midwest, farmers are revitalizing vast tracts of corn and soy fields, reducing their reliance on costly inputs and seeing their soil come back to life. In the brittle, often arid landscapes of Australia, ranchers are using holistic plant grazing to restore grasslands, turning dusty paddocks into productive pastures. and in parts of South America, from the plains of Argentina to the small holdings of Brazil, agricultural communities are rediscovering these principles to build more resilient and profitable food systems. These pioneers are proving that you can increase biodiversity, improve water cycles, and sequester carbon while still running a successful business. They are demonstrating that innovation isn't always about inventing something new and high tech. Sometimes the most profound innovation is about rethinking what we've forgotten and having the wisdom to work with the genius of nature. As our world becomes increasingly urbanized, a fundamental challenge emerges, one that is woven into the very fabric of our daily lives. By 2050, it's projected that more than 2/3 of all humanity will reside in bustling metropolitan centres. This historic demographic shift creates an ever-widening gap between where we live and where our food is grown. The traditional model of agriculture, characterised by vast rural farms, relies on complex and lengthy supply chains to bridge this distance. Every fruit, vegetable, and leafy green we consume embarks on a journey that can span thousands of miles, a journey that consumes vast amounts of fossil fuels, contributes to carbon emissions, and introduces countless points of vulnerability. This logistical marathon not only strains our planet's resources, but also diminishes the quality of our food. With each passing day in transit, fresh produce loses vital nutrients and flavour. A significant portion, sometimes up to 40%, spoils before it ever reaches a consumer's plate, representing a staggering waste of water, energy and labour. The modern city, for all its marvels of engineering and culture, is a food desert in disguise, almost entirely dependent on a fragile, distant system. But what if we could reimagine this paradigm? What if we could bring the farm to the city? This is the promise of urban agriculture, a revolutionary trend that is taking root in cities across the globe. Visionary architects, engineers, and agronomists are collaborating to close the food gap, transforming underutilized urban spaces into productive oases. They are constructing hyper-efficient vertical farms that climb stories high inside skyscrapers, converting abandoned warehouses and subterranean tunnels into state-of-the-art hydroponic systems, and turning barren rooftops into vibrant soil-based gardens. These innovative farms are designed to produce fresh, healthy food right where it's needed most, in the heart of our communities. By decentralizing food production, urban agriculture creates a more resilient, responsive, and sustainable food system capable of weathering supply chain disruptions and reducing our reliance on long-distance transport. It's a movement that's not just about growing food, it's about cultivating healthier cities and more connected communities. At the core of this revolution is a suite of technologies known as Controlled Environment Agriculture, or CEA. These systems create the perfect growing conditions 365 days a year, independent of weather or season. Instead of sunlight, they use advanced LED lighting, precisely tuned to the specific wavelengths that drive photosynthesis. By providing an optimal spectrum of red and blue light, these farms can accelerate plant growth while consuming significantly less energy than traditional lighting. Water, one of agriculture's most precious resources, is used with unparalleled efficiency. In hydroponics, plants are grown without soil, their roots bathed in a circulating nutrient-rich water solution. This closed-loop system allows farms to capture, recycle, and reuse nearly all of their water, often using up to 95% less than conventional field farming. Because the environment is meticulously controlled, from temperature and humidity to CO2 levels, the need for chemical pesticides, herbicides, and fungicides is completely eliminated. This results in produce that is not only cleaner and safer, but also consistently high in quality. This fusion of agriculture and technology is already reshaping the food landscape in some of the world's most forward-thinking cities. In Singapore, a densely populated island nation that imports over 90% of its food, the government has launched the 30 by 30 initiative, aiming to produce 30% of its nutritional needs locally by 2030. Vertical farms are a cornerstone of this strategy, enabling the country to maximize its food output with a minimal physical footprint. Similarly, in the arid climate of Dubai, urban farming is a critical tool for food security. The city is now home to Bustanica, the world's largest hydroponic farm, capable of producing over 1 million kilograms of high-quality leafy greens annually, all without using a single drop of soil. The result of these efforts is a paradigm shift in freshness. Produce can be harvested in the morning and be on a restaurant plate or a grocery store shelf by the afternoon. This hyperlocal model drastically reduces food miles to food meters, delivering unparalleled flavor, peak nutritional value, and a dramatically extended shelf life. Urban farming is proving that with innovation, even the most unlikely places can become breadbaskets, making cities like Singapore and Dubai pioneers on the path to self-sufficiency in fresh produce. Artificial intelligence is also revolutionizing global food logistics. Machine learning models now forecast crop yields, track global demand, and prevent food waste by predicting when and where surplus will occur. Blockchain technology is being used to trace food from farm to fork, ensuring transparency, safety, and fair trade. For consumers, this means every apple, fish, or grain of rice can have a digital passport revealing its origin and journey. But innovation also faces challenges, and technology can widen inequalities if it benefits only large agribusinesses and leaves small farmers behind. The digital divide, access to internet, capital, and training could create a new kind of inequality in the food system. That's why many organizations, from the FAO to private startups, are focusing on inclusion, developing low-cost sensors, open-source data platforms, and community-based microgrids that make precision farming affordable for everyone. The future of food is not about replacing farmers with machines, it's about empowering them. In Kenya, solar-powered irrigation systems are helping smallholders withstand droughts. In Indonesia, blockchain cooperatives are allowing rice farmers to sell directly to consumers. In Brazil, drones monitor forest boundaries to prevent illegal deforestation. These are not isolated stories, they are signs of a global transformation. Climate change, however, remains the ultimate test. Rising temperatures threaten staple crops like wheat, corn, and rice, which feed billions. Scientists are developing climate-resilient varieties that can survive floods, heat, and poor soils. But the race is on. Every year lost means more instability in the global food chain. According to the UN, we'll need to increase food production by 50% by 2050 to meet demand, even as arable land shrinks. The only path forward is smarter, cleaner, and more circular. Imagine a future where farms are carbon negative, cities grow their own food, and every meal leaves a positive footprint. A world where waste is recycled into fertilizer, where data guides every harvest, and where agriculture heals rather than harms the earth. That future is being built right now, signed in research labs, greenhouses, and startup hubs around the world. The next agricultural revolution won't happen in one country. It will be global, shared across continents, cultures, and technologies. It will require collaboration between governments, scientists, and farmers. It will demand investment in education, equity, and access. But if we succeed, we will have solved not only the challenge of hunger, but the challenge of sustainability itself. Food is more than survival, it's culture, identity, and connection. And as humanity enters a new era of abundance powered by intelligence, one truth remains: the future of food is the future of us all. This is Eco-Innovatech, exploring how innovation and sustainability are reshaping life on Earth.